So that warm-up hand up that I had you submit on 1-4 was getting you thinking about solving absolute values. Absolute value is the distance away from 0 a number is on the number line. So again, yep. Absolute value is the distance from 0 a number is on the number line. Assignments are going to need to be PDFs in a single document. Okay. So again, absolute value represents the distance from 0 a number is on our number line. So we solved equations in lesson 1-3. That was a big part of the quiz you just took. And what we are doing now is reviewing that, making sure we are all okay with solving. So you have 5x minus 6 equals 40. You need to distribute the 5x. Add the numbers. Divide by 5. Subtract over your 6b. Divide by -1. And we get b equals 16. And then in 3, first thing you want to do is combine like terms on the same side. So 2y and 6y is 8y. 15 and 8 is 23. Then add your 2y. Divide by 10. And y equals 2.3. Okay. So we have 2 new vocabulary words. We have an absolute value, which is the distance a number is from 0 on the number line. An absolute value is really a piecewise function. So the absolute value of x can really be written as if x is greater than or equal to 0, then the absolute value of x is x. If x is less than or equal to 0, then the absolute value of x is negative x. So the absolute value of x is really a piecewise. Now when we look and solve absolute values, we're going to get something called an extraneous solution. This is a solution that you get when you solve the problem correctly, but when you check it, it does not check. So it's an answer you get when you solve correctly, but when you check, it does not check. It means in some way you get a negative over a positive or a positive over a negative. And we'll see what that means here in a minute. So again, an extraneous solution is a solution you get, but is not true when you check. Okay? So we have 3 steps that we use to solve an absolute value equation. The first step is to isolate. So in example 1 and 2, both of those absolute values are isolated. Put the fan away, please. Next time I'll take it. Step 2 is to rewrite it as 2 equations and solve. And then step 3 is to go back through and check. So what we're going to do first is it's already isolated, so 1 is done. 2 is to rewrite and solve. So we're going to rewrite it as 15 minus 3x equals 6. So that's the positive, and then the negative is 15 minus 3x equals negative 6. Cool. So then what we do is we solve for x in both equations separately. So you subtract 15 divide by negative 3. And you get x equals 3 and x equals 7. So now what you need to do is take 3 and take 7 and check them in the original. So it's absolute value 15 minus 3 times 3 equals 6. So 3 times 3 is 9. 15 minus 9 is in fact 6. So you get 6 equals 6, and it checks. Over here, absolute value of 15 minus 3 times 7. 3 times 7 is 21. 15 minus 21 is negative 6. But the absolute value of a negative 6 is a positive. So I get 6 equals 6, so it checks. When you're checking, you should always get like 6 equals 6, or you're going to get negative 6 equals 6, and then it fails. But it should always be the same number equal. Okay, number 2, absolute value is isolated. So then we split it into the positive and negative side. So you get 3x plus 2 equals 7. And 3x plus 2 equals negative 7. Solve for x. Once you have your 2 solutions for x, you have to check them. When everything's positive, it's not really a big deal. 3 times 5/3 5. 5 plus 2 is 7. So I get 7 equals 7. That one checks out. Over here on the right, you have to be a little more careful. 3 times negative 3 is negative 9. It doesn't become positive and then you add them. It's negative 9 plus 2. So you get negative 7. But the absolute value of negative 7 is 7. So it also checks. Okay, and number 3, we now have a little bit more of a problem. We have to isolate the absolute value. So in number 3, you have to first move over the 4. And then you have to divide by -2. Once your absolute value is isolated, now you can split the two terms. You cannot split the problem into a positive and a negative unless the absolute value is alone. You cannot split the problem into a positive and a negative unless the absolute value is alone. I can guarantee on your test someone will split it before it's alone. So 9 has is really 4.5. 4.5 minus 9 is negative 4.5. And a negative 4.5 and a negative 9 gives a negative 13.5. Always have to check. You can check into the original. So you're only ever working down one side. The other side stays the same. So that equals -5. You're not moving over the 2 or adding the 4. You're leaving at the -5. Then we're going to check with the negative 13.5. So negative 13.5 plus 9 is negative 4.5. And then at this point, we get down to the same math we had before. So since the math is the exact same, you know it checks. Okay? In number 4, once again, you have to isolate the absolute value. So we're going to subtract 5 from both sides. Divide by 2. Once my absolute value is isolated, now I can split my problem. So one side's always positive, the other is negative. Our answers are not opposites of each other. I want to make that known too. Like this is negative 4.5 and negative 13.5. It's not -4 and +4. Their answers are very different. We're going to check. Three times 5 is 15. 15 minus 1 is 14. 14 times 2 is 28. 28 plus 5 is 33. Three times -13 is -13. -13 minus 1 is -14. Absolute value of -14 is 14. 14 times 2 is 28. 28 plus 5 is 33. it also checks. All right, so number 5. The absolute value in this example is isolated. The absolute value in this example is isolated. However, now you have to be careful about the right side of the equation because it's not just a singular number, it is an expression. So when I make everything on this side that doesn't have the absolute value negative, I have to change the signs of both terms on the other side. So the positive just drops the absolute values. So one piece is 3x minus 4 equals negative 4x minus 1. It's exactly like it is in the problem. The other side, you have the 3x minus 4, but now it's negative the whole part. So it's 3x minus 4 equals positive 4x plus 1. Both terms change sign. Not just the first term, but both terms. Now we're going to solve for x on both parts. So over here, I might add my 4 and subtract my 4x. So I get x equals negative 5. And then on the left, I have 3x minus 4 equals negative 4x minus 1. So we have to add 4x. So you get 7x minus 4 equals negative 1. Add 4. So you get 7x equals 3, or x equals 3/7. Now we're going to check them. Okay. So on the right, you have 3 times 3/7. So that's 9/7 minus 4, which is an absolute value of negative 19/7. So that becomes positive 19/7. And then here you have negative 4 times 3, which is negative 12/7 minus 1. So what do we already notice about the right side? You have negative 12/7 minus 1. Even if the numbers are the same, which I just need some space, you get negative 19/7. Is a positive 19/7 the same as a negative 19/7? Is a positive the same as a negative? No. So that means that x equals 3/7 fails. It is an extraneous solution. So that's what I was saying. You're going to get the opposite number when you check. So let's check x equals -5. And also, just because one number fails doesn't mean the other one will fail. -15 minus 4 is absolute value of -19. -20 minus 1, or sorry, +20 minus 1, because a negative times a negative is a positive, gives 19. 19 equals 19, so it checks. Number 6, we split, so you get 2x plus 3 equals 3x plus 2, and then 2x plus 3 equals -3x minus 2. Solve for x. So we get x equals -1 and x equals +1. Check them both. Five equals 5 for +1. -2 plus 3 is 1. So you get 1. -3 plus 2 is -1. So -1 does not equal 1. Therefore, this is an extraneous solution. Okay, and then last but not least, absolute value of x equals x minus 1. So you get x equals x minus 1. X equals -x plus 1. So you subtract x from both sides. X minus x is 0 equals -1. Does 0 equal -1? No. So that part is just no solution. It's not extraneous. That left side gives you a no solution. Here we get 2x equals 1. So you get x equals 1/2. Checking that. We get 1/2 equals -1/2. So this is extraneous and fails. So since you had no solution on the left and an extraneous on the right, this equation has no solution. This equation has no solution. There are no values for x that will ever make that true, no matter what you plug in. So there's a difference, and that was kind of the point between extraneous and no solution. There is a difference between extraneous and no solution. All right, so adult tennis rackets have a 100 square inch head plus or minus 20 square inches. So that means they can range from 80 to 120, right? Because it's 100 plus 20 or minus 20. Now what we want to do is create an absolute value to represent that. So basically, these are like your answers. You got the 80 and 120 for your answers. How can you write that as an absolute value? So what we could say is that the absolute value of 100 minus x has to be less than or equal to 20, right? So if you plugged in 120, you'd get the absolute value of 20 is 20. If you plugged in 80, you'd get 120 is 20. So your absolute value is 100 minus x has to be less than or equal to 20 to get you to that range of answers. Okay, so once again for you, it's the next page in your packet. Also matches textbook page 30, 14 to 34 all.